And so for those of you guys who are new, if you can't come to a lesson for some reason, I post all of them in Google Classroom, and I'll show you where to find those at the end of class as well. All right, so today is the 28th of October. We're gonna talk about slope a little bit more today. So make sure you have out notebooks, calculators, pencils, and then this is our do now problem. So this says, give the slope of the graph and the unit rate. So this past few days, we've been talking about different ways to find the slope. So we can use that rate of change formula, that y2 minus y1 over x2 minus x1. So we can use that. We can also just take, sorry, I'm blanking. K equals y over x. So that was our constant of proportionality. And if you guys remember, a graph is proportional if it's a straight line and if it goes to the origin. So if it goes right here at 0, 0. So that this line already is a proportional relationship. So we can use that, we can use this formula to figure out what our slope is. And I'll explain the difference between using the rate of change formula and the constant of proportionality in a minute. I think that using the rate of change, I'll write that on top of it. So this is the rate of change formula, or the slope formula. They're kind of like the same. I think it causes a lot more work. So to make it easy on yourself, we're just gonna look at, we're gonna put y over x since it's a proportional relationship. So we're gonna find the change in y, we're gonna find change in y over change in x. So I'm gonna look at this point right here. That's gonna be my x, and this point right here is gonna be my y. And the reason I'm looking at these is because right here on our graph, I'm trying to make a dot, is where that line meets, it like intersects with our y and x axis. Same thing for, let's see if I can find another one. Right here, same thing. So it is intersecting at y and x as well over there. So I could pick this point right here, or I could pick this point right here to figure out whichever one. So this graph I can already tell is moving at increments of 2, because in 1, 2, 3, 4, 5 jumps, it's up to 10. So that means that each of these notches is going to represent 2. So 2, 4, 6, that kind of thing. Same thing on the side, we're jumping at the rate of 2. So it's going to go 2, 4, 6, 8, that kind of thing. And I know it's hard to write on this thing, so I'm trying. All right, so we're going to take y, which in this case is going to be 2. And then we're going to take x, which is 2. Well, so I'm doing this formula right here. So I took y and x and I divided. So y divided by x, 2 divided by 2. Our constant of proportionality, well, 2 divided by 2 is just 1. Okay, so the constant of proportionality is going to be 1. The slope, if we look at this line over here, we're going to have, let's see, 11 and 10. So let's see, actually, hold on, let me get my eraser because there's a lot going on over here. So let's see, 5 miles every 6. Okay. So what I'm seeing actually, sorry, I know it's kind of hard to see this graph. I can't actually tell if this point is going through now. So 5 miles every 6 hours. To make it easy, I'm making it more complicated than it needs to be. Again, guys, this is my first time teaching this specific subject, so I'm kind of trying to think of how I can make it easiest for you guys to understand, so bear with me. I'm not trying to confuse you guys. So I know you're probably writing stuff all over your paper, I'm sorry. So Jorge, 5 miles every 6 hours. So in 5 miles, he goes, or in 6 hours, he goes 5 miles. So we can find the unit rate for that by just taking, so 5 miles every 6 hours. We want to figure out in how many, in 1 hour, how many miles does he go? So if we're trying to figure out the per one, our miles is going to be our y, which we already know, we can already see that on our graph, and our 6 hours is going to be our x. So time in hours is going to be our x. Remember, we're just trying to figure out the change in y over the change in x. So if we want to find the unit rate, we can just take 6, I'm sorry, y. Gosh, guys, I'm sorry. y, because we're taking y divided by x, which is 6. We can see that every 6 hours. So 5 divided by 6. So our slope is going to be 5 divided by 6. So 5 divided by 6 is going to be 0.83. So our slope is going to be 0.83. And what this means that every 1 hour, so remember y over x, every 1 hour he goes 0.83 miles, and that's our unit rate. So on your quiz on Friday, you'll see, excuse me, you'll see unit rates. So when we're talking about per one, the price per one banana, the price per one cup of coffee, the speed per 1 mile or per 1 hour, that kind of thing. So this means that in 1 hour, he goes 0.83 miles or 5/6 of a mile. So we can use that. That's going to be our slope of our graph. So that is our rate of change. Again, the constant of proportionality, the rate of change, and the slope are kind of all related. They're kind of all the same type of thing. When we use the rate of change formula, this is where we're selecting 2 points and we're trying to figure out the difference in 2 points. And we've kind of seen that throughout this week. So if we had, if we had a dot here and a dot here, I know they're not, but if we wanted to find the rate of change between those 2 dots, we could by using the rate of change formula. And I'll go over some more examples here in a minute. And again, if you have any questions, you can type them in the chat or you unmute yourself. I know I'm trying not to confuse you guys. I'm going to do a little bit better of a job planning for next week. It's been chaotic because I teach in person and I teach online. So I have to plan for both classes and you guys are both learning totally different topics. So I have to go from teaching algebra to teaching this. So it's kind of like I'm a little bit of a switch up in my brain. All right, so give the slope of the graph and the unit rate. So we want to figure out the unit rate. To find the unit rate, we're going to take y divided by x. So we kind of talked about k, so the constant of proportionality, k equals y over x. That's going to be, the constant of proportionality is going to give us the unit rate. So we're going to take, so y is going to be 5, x is going to be 4. And if you have a question about where I'm getting these numbers, make sure you're letting me know. But all I'm doing, so this is y, this is x. So this is saying in 4 hours, I go 5 miles. So I can take total miles divided by time to figure out how many miles I would go in 1 hour. So 5 divided by 4, I think is 1 1/4. So 5 divided by 4. So 1.25, so 1 1/4 or 1.25 or 1. So this means that if we had like an extra box on our table that we could do, this would mean that in 1 hour, we would travel 1.25 miles at this pace, at this rate. So then it says, give the slope of the graph. Well, we can go ahead and we can take the rate of change so we can find the slope. We can take these 2 points. So this is kind of where we use that rate of change or that slope formula. So I'll write it down here for you guys so you can get it written down. So we've got y2 minus y1 divided by x2 minus x1. So that is our slope formula or rate of change formula. They're similar, they're the same thing. You'll just hear them both. They have 2 names for some reason, but it's just so you can kind of understand that the slope is the steepness of a line, but it is measuring the rate of change of the line as well. So we're going to pick 2 points. So I picked 5, 4 and 10, 8, or 8, 10, I guess, x, y. So our points would be, I'm going to write this one. So this is, so if you guys remember from yesterday or from Monday, I think we talked about rate of change formula. We've got to pick a point. So I'm going to make this point 1 and this point 2. That's what those y2s and y1s mean. So y2 is going to be the y value of the second point. So y2 is going to be this 10 right here. So this is y, and this is our second point. So we're going to take 10 And then we're going to take y1, which is the y value on our first point. So y minus 5. And I'm trying to color code so you guys can see where I'm getting these numbers. Over x2 minus x1. So I'm going to look at x2. x2 is 8. And then y1 or x1 is 4. Oops, I'm going to make that purple. Minus 4. All right. So 10 minus 5 is going to give us 5. 8 minus 4 gives us 4. So what I want to make sure that you guys are making the connection. If you notice that constant of proportionality that we found right away when we took 5 divided by 4, that constant of proportionality is our slope. When we use the slope formula, we got the exact same thing, that rate of change. So when it says find the slope of the graph and the unit rate, all you have to do to find the slope of the graph is take a y point or a y divided by x. So you need to select a point. So you could even select 15, 12, 15. So you could type in 15 divided by 12 and you would get the same thing, 5/4. So the slope is always going to be the same. So you figure out slope by taking y divided by x. So that constant of proportionality. I know I'm writing a bunch of stuff all over the screen. So we take y divided by x to find slope. The reason we use this formula is to find the rate of change between 2 points, and it should be able to also give us the slope. So the rate of change and slope are the same thing. When we're talking about unit rate, you're going to see unit rate on your quiz. We're talking about per 1. So to figure out, let's see, in this case, we've got time and distance. So we've got hours and miles. So we want to figure out how far in miles we go in 1 hour. So we did that by taking 5 divided by 4, and that gave us 1.25. So that's the distance. That's y over x still. That's still the same thing, y over x. So 1.25 miles in 1 hour. I know it's kind of a lot. All right. The equation y equals 0.5x represents the distance Henry hikes in miles over time in hours. The graph represents the rate that Clark hikes. Determine which hiker is faster. Explain. So if you guys remember from last week, we talked about the constant of proportionality formula. So k equals y divided by x. You can also rewrite that formula as y equals kx. So these formulas are the exact same thing. The only difference is this is how we would write it in an equation. So we would find the constant of proportionality by using this formula, and then we would represent the constant of proportionality in an equation by writing it in this format. So that's when you see y equals a number x, that like in this case, we've got, I'm sorry, I know I'm writing all over the place again. When we've got 0.5, that's our constant of proportionality. So that is our rate at which Henry is hiking. So let me go ahead and undo some of this. Nope, nope, nope. My smartboard is rebelling against me. Of course it is. Let's see, come on. All right, I just wanted to get that circle out of there. All right, so Henry hikes 0.5x. So what this means is he hikes, so the constant of proportionality, that is his pace. So time at h is going to be our x. And distance in miles is going to be our y. So this is saying that Henry hikes 0.5, that's his pace, per hour, and that's going to result in his total distance, which is y. So that's what that equation is saying. The graph represents the rate in which Clark hikes. So Clark, let me get my other highlighter. Clark is over here. So what we need to do is we need to figure out a place to put a dot, a point on the graph. So we need to figure out where a point on the graph where it meets x and y. So like putting one right here would make no sense because it's not touching a perpendicular part of the graph where X and Y meet. That would make no sense. We need to put a point on the graph where X and Y meet the line. And you can do that on any of these parts. If you guys, so in the chat, go ahead and tell me that you understand what I'm saying. So make sure say, I'm confused, or say, I understand. When I say, I'm trying to find a point on the graph that says that where that line meets the x-axis and the y-axis. So in the chat, go ahead and say, yep, I get it, or nope, I don't understand what that means. All right. So Namaya, thank you. I'm glad you're good. I'm waiting on Kishay and Diego, but I'll go ahead and leave that over. I'll put the chat away so we can keep moving. So I'm looking for a point to pick from the graph. So I'm just gonna pick any point. I'm gonna go ahead and pick this one right here where my mouse is, just because you can pick any point that the graph intersects on that line. So I'm gonna go ahead and pick that one. So I'm gonna go ahead and make like a little line so I know that this is Clark. So I'm gonna go, this is Clark's information over here. So I'm gonna make a point for Clark. So he has got, so remember, this is one of those graphs that moves at 2. So every time one of these notches moves, it's moving at 2. So this point right here on the x-axis right here is gonna be at 1, 2, 3, 4. So it's gonna be at 4. And then if I go over here, it's gonna be, so we've got 1, 2, 3, 4, 5, 6. So it's gonna be at 4, 6. So remember, to get our constant of proportionality, all we need to do, we've got X, we've got Y. I already picked a point. So all I have to do is take K equals Y divided by X. So I'm gonna take K and I'm gonna say 6, because that's my Y value. So 6 divided by 4, because that's my X. So 6 divided by 4 is 1.5. So K equals 1.5. So what I'm trying to say here, 1.5 is Clark's speed or rate or slope or rate of change. That is his pace that he is going. And I know it sounds like weird, like why are there so many terms for it? There's so many terms for it because somebody in math thought that there needed to be, I guess, I don't know. But if we can remember this formula, so this setup, we're gonna write, so we're gonna have Henry and we're gonna have Clark. So Henry and Clark have their own set of lines. So Henry, we have his equation. So we've got Y equals 0.5x. Remember that 0.5 is representing the constant of proportionality. So that means that his speed is 0.5 miles per hour, basically. And then our K, or our constant of proportionality for Clark, is 1.5. So to use this formula, so we're just setting it up again, we're gonna take Y equals, we're gonna sub in 1.5 for that K, 1.5, and then we've got X. So we're comparing these two. So this is saying that if we were to multiply 0.5 times how many hours he went, we would get a total distance. If we were to multiply 1.5 times however many hours he hiked, we would get a total distance. So because Clark's pace or rate of change is more, Clark is hiking faster. So Clark all right. Any questions about that one? Okay. So write an equation relating the variables in each table. So I'm going to show you guys Remember, so we've got k equals y over x. And we can also write that as y equals kx. So those are the same thing. Those are the same formulas. The only thing is to find k, we're going to take y divided by x. So in this case, we can take y divided by x. In this case, we can take y divided by x. So our y value is 15. So we're going to take 15. Our x value is 1. We're going to divide that by 1. So 15 divided by 1 is 15. So 15 is k. So we're going to plug that number in for k and write an equation for this table. So we're going to take y equals, we're going to plug in 15 for our k value, which is our constant of proportionality. So we're going to plug in 15. And then we're going to write x. That's it. That's all you have to do to find an equation relating the variables to each other. Because now I want to explain kind of why this makes sense. If we had y equals, let's say we wanted to put in 4. So y equals 15. So we're going to sub in, instead of using x, we're going to sub in this 4. So 15 times 4. Well, 15 times 4, oh, sorry, 15 times 4 gives me 60. So it checks out. So what this means is this formula, if you were to plug in any value for x, you would always get a y that would be proportional. So I'm trying to hope that my goal for this lesson and for this unit is for you guys to understand the relationship between numbers and between tables and between graphs too, because we've been kind of working on that. So we're going to use the constant of proportionality again in the second one. So I'm going to take my y value, which is 6, divided by my x value. So remember, y always divided by x. So y over x. If you can't remember this, I remember one of my 8th grade teachers was like, why is my ex so annoying? Talking about ex-boyfriend. So y over x, why is my ex so annoying? That's funny. So we're gonna take 6 divided by 16. So 6 divided by 16, it's gonna give me 0.375. So 0.375. And that's k. So remember, we used our constant of proportionality formula to figure out what our pace was or rate was for time and distance. So we're going to use our equation setup to write it. So we're going to take y equals 0.375 x. Okay, that's all you have to do. So so when you see a problem like this and you need to create an equation, all you've got to do is take y divided by x. That's going to give you your pace or rate or constant of proportionality. And then to plug that, to make a formula or an equation from that, you're going to just do y equals k times x, or your rate times x. Any questions about that? All right. A Canadian goose migrated at a steady rate of 3 miles every 4 minutes. Hold on 1 second. Fill in the table to describe the relationship. So on your papers, I would kind of sketch. You don't necessarily have to draw a table, but if you have lined paper, maybe you can write time in minutes, in distance, in miles, and then kind of make a table. So I'll give you a minute to do that real quick. I know I just realized that I'm talking fast, acting like you have all this written down already, and I'm sure you guys are like scrambling to take notes or something. All right, so Canadian goose migrated steady rate of 3 miles every 4 minutes. So in 4 minutes, they went 3 miles. So we need to figure out how to fill in the rest of the table. So what we can do is we can figure out our constant of proportionality. So remember, K equals Y over X. So we're going to take 3 divided by 4, which is 3/4. So 3 divided by 4, and that's going to give us 0.75. So K is going to be 0.75. So all I did was I took Y divided by X, and that gave me 0.75. Now, for this part, I want to write an equation, and I know it doesn't say to write an equation, but it makes our life a little bit easier when we do. So if you guys remember from the last slide, Y equals KX. So K is 0.75, and then X is going to be our X values. So all I need to do now is I need to multiply any X values by 0.75, and I need to divide any Y values by 0.75. So to figure out what, for this next part, for 8, I'm going to take 0.75 times 8, and that's going to give me 6. For the next part, I'm going to do the opposite. So to get from X to Y, I'm multiplying by 0.75. To get from Y to X, I'm going to divide. So I'm going to do 9 divided by 0.75. And that's going to give me 12. Okay. Same thing with the next one. I'm going to do 12 divided by 0.75. That's going to give me 16. And then finally, 20. I'm going to have 20 times 0.75, and that's going to give me 15. All right. So we filled in our table. Make sure you're letting me know if you have any questions on how I'm doing anything, why I'm doing anything. But I figured out what our rate of change was, or our, and this one is constant. On your quiz, you'll also see, and I told you guys this yesterday, you'll see questions like, is this constant or is it variable? If a table is constant, it's moving at the same rate. So if you notice, this table is moving at the same rate of +4, and this bottom part is moving at the same rate of +3. So that is a constant relationship. So you have to basically determine if the table is proportional or not. And we'll do more practice next week. I don't know if I'm going to introduce more like new stuff next week. I think I'm going to just have us practice together a little bit, a couple more examples, maybe create a worksheet or something for us to go over together. So graph the relationship. So, oh, this is going to be difficult. And if you don't have graph paper, you can either just watch or create your own graph, which would take a while. But so if I'm going at X is 4, so I'm going to go here and then up 3, 1, 2. So oh yeah, it's definitely hard to graph on this thing. So then I'm going to go to 6, and then I'm going to go to 8. So 6, 8. And I'm going to go to 9, 12. So 9, 12, sort of. So if we can tell, our graph is going to look something like this. And we're going to practice graphing points next week because I realized that some people actually aren't very comfortable with graphing points or identifying points on a graph. So that'll be, if you're good at that, that'll be some easy points for you. If you're not good at that, that'll be some good practice and good practice and review. All right, so this says find the slope of the graph and describe what it means in the context of this problem. We already found the slope. It's 0.75. The constant of proportionality, we know that this slope, it is changing at a rate of 3/4. So this 3/4 means that, let's see if, I'm trying to find one of my points. So let's see, 8, 6. So 8, 6, 6, wait, 6. Oh crap. All right, well, I just realized that I have to get wrapped up because I have class in a few minutes, like in-person class. So slope of the graph is going to be 3/4, which means our rise is 3, our run is 4. And we'll kind of go over more about what that means soon. So I'm going to go ahead and stop our recording for today.